In 2023, the James Webb Space Telescope pointed its mirror at a nursery of baby stars and found something orbiting out there that, according to the accepted rules of physics, is not supposed to exist. Not one object, not a handful. Dozens of them, paired together, drifting freely through space with no star, no sun, nothing anchoring them to anything at all. And 2 years later, when astronomers pointed their instruments at a pair of these objects specifically to study them more closely, they picked up something else entirely. A faint unexplained radio signal coming from exactly the kind of object that isn't supposed to be capable of producing one. Everybody, this is the real story of jumbos, officially known as Jupiter mass binary objects, and it remains one of the most genuinely unresolved mysteries in modern astronomy. A discovery so strange that some researchers have spent the last 2 years trying to prove it isn't even real, and so far they haven't been able to. This isn't a story built on speculation stitched together from a single ambiguous data point. It's a discovery independently reproduced in 2 different parts of the galaxy, actively debated in published, peer-reviewed literature, with a second, entirely separate mystery layered directly on top of the first. Let's start with what Webb actually found, because the setup matters enormously for understanding why this discovery broke so many assumptions at once. In October 2023, an international team of astronomers, led by Samuel Pearson and Mark McCarran of the European Space Agency, published findings from a deep survey of the Orion Nebula, one of the most active star-forming regions visible from Earth, roughly 350 light-years away. Within a specific area of the nebula known as the trapezium cluster, Webb's infrared vision picked up more than 500 free-floating planetary mass objects, worlds with no host star at all, simply drifting through the nebula on their own. Free-floating planets themselves aren't new to astronomy. They've been documented for more than 20 years, first spotted by ground-based telescopes like the United Kingdom Infrared Telescope in Hawaii, and the leading explanation for how they form is straightforward enough. A planet forms normally within a young solar system, then gets violently ejected by gravitational interactions with other planets or nearby stars, sent tumbling off into the galaxy on its own, untethered forever. It's worth understanding just how common these solitary rogue worlds are thought to be across the galaxy as a whole, because it puts the specific jumbo mystery in proper context. NASA estimates that solitary rogue planets, the ordinary unpaired kind, may actually outnumber stars in the Milky Way by a ratio of roughly 20 to 1, meaning trillions of these homeless worlds could be drifting silently through our galaxy alone at any given moment, far outside the range of anything but the most sensitive infrared telescopes ever built. Against that backdrop, a single free-floating planet isn't shocking anymore. Astronomers have grown accustomed to the idea that ejected worlds are simply a normal, expected byproduct of how planetary systems form and evolve over time. What Webb found buried within that population of 500-plus rogue worlds is where the story stops being straightforward. 80 of these objects, 40 pairs in total, weren't drifting alone. They were locked together, orbiting one another as loose, gravitationally bound binary systems, each object comparable in mass to Jupiter, separated from their partner by distances reaching up to 390 times the gap between Earth and our own Sun. McCarran and Pearson gave them the nickname Jumbos, short for Jupiter mass binary objects, and the name stuck immediately across the astronomical community, both because it was memorable and because nobody had a better explanation ready to replace it. Here's exactly why that pairing broke the existing model. If a single rogue planet gets kicked out of its home solar system through gravitational chaos, that's a well-understood, thoroughly modeled process. But getting 2 planets ejected simultaneously, at the same time in the same direction, while somehow remaining gravitationally bound to each other well enough to keep orbiting one another afterward, is an entirely different physical problem. The researchers themselves acknowledge this openly in their published paper, stating plainly that how pairs of young planets could be ejected simultaneously and still remain bound to one another, even weakly, at such wide separations, remained quite unclear based on current theory. That's a research team publishing in the scientific literature and telling the world directly that their own discovery didn't fit the models they had. And it's not just the pairing itself that broke the rulebook, it's what these objects even are, category-wise, that adds a whole separate layer of confusion. Astronomers have long relied on a specific physical boundary to separate planets from something called brown dwarfs, sometimes nicknamed failed stars, objects too small to sustain the kind of hydrogen fusion that powers a true star, but still large enough to briefly fuse a heavier form of hydrogen called deuterium early in their existence. That boundary sits at roughly 13 times the mass of Jupiter. Below that threshold, an object is generally classified as a planet. Above it, once an object reaches somewhere around 75 to 80 Jupiter masses, gravity finally compresses its core enough to sustain full hydrogen fusion, and it becomes a genuine, if extremely faint, star. Jumbos sit almost precisely in this contested gray zone, with masses ranging from roughly 0, 7 to 13 Jupiter masses, putting the majority of them squarely in true planetary territory by mass alone. But mass isn't the only thing that matters to astronomers trying to classify an object like this. Formation history matters just as much, arguably more, and that's exactly where jumbos create such a headache. A true planet, by most working definitions, forms within a disk of material orbiting a star. A brown dwarf, by contrast, typically forms the same way a star does, through the direct gravitational collapse of a cloud of gas, just one that never gathered quite enough mass to fully ignite. Jumbos, drifting freely with no host star and no evidence they ever had one, don't cleanly fit either formation story, forcing astronomers to seriously consider whether some of these paired worlds might actually be sub-brown dwarfs, an even rarer, less understood category of object that forms in isolation, directly from collapsing gas, without ever being part of a genuine planetary system at all. Two competing explanations emerged almost immediately, and both come with serious problems. The first suggests these jumbos form the same way stars do, through the direct gravitational collapse of small clouds of gas and dust, essentially treating them as scaled-down, failed attempts at star formation rather than true planets at all. This theory has a real problem of its own, though, because the smallest known star-forming gas clouds observed anywhere in the galaxy still tend to produce objects considerably more massive than the smallest jumbos detected, some of which sit at less than a single Jupiter mass, right at the very edge of what direct collapse is thought to be physically capable of producing. The second explanation returns to the ejection scenario, proposing that these paired worlds really were kicked out of their original planetary systems, but somehow managed to stay loosely bound to their partner throughout that violent process, an outcome that existing computer simulations of planetary ejection struggle to reproduce with any regularity. When astronomers model the kind of chaotic gravitational encounters that typically fling a planet out of its home system, whether through close interactions with a passing star or violent instability between multiple planets competing for stable orbits, the resulting ejected object almost always flies off entirely on its own. Simulating two objects escaping together at compatible velocities in a way that leaves them still gravitationally linked afterward has proven remarkably difficult to reproduce reliably, adding weight to the idea that whatever process created jumbos might not be fully captured by either of the two standard explanations astronomers currently rely on. There's a third, more exotic possibility some researchers have floated as well, though it remains more speculative than the other two. Some scientists have wondered whether jumbos might represent a genuinely new formation pathway entirely, something in between the disk-based planet formation process and the direct gas collapse process typically associated with brown dwarfs and stars, a kind of hybrid mechanism nobody had previously identified, simply because nobody had ever detected a population of objects quite like this to study in the first place. Confirming or ruling out that possibility will likely require additional observations of other young, actively star-forming regions across the galaxy, comparing how frequently jumbo-like pairings show up in different environments with different densities of stars and different amounts of surrounding gas and dust. If a real, still unresolved cosmic mystery like this is exactly the kind of space science you come here for, subscribe now, because the story doesn't end with the discovery itself. It gets stranger from here. Because in the 2 years since that original 2023 announcement, the scientific community has been split, and some researchers have actively tried to prove jumbos don't exist at all in the way they were originally described. In 2025, a research team led by Richard Parker, working alongside University of Sheffield astrophysicist Simon Goodwin, ran detailed computer simulations specifically testing how long a loosely bound pair of Jupiter-mass objects could actually survive in an environment as crowded and gravitationally chaotic as the Trapezium cluster, packed full of young, actively forming stars, whose gravity would constantly be tugging at anything nearby. Their simulations suggested these pairings should be fragile, easily torn apart by nearby stellar interactions, raising a genuine question about whether what Webb detected was really a population of stable, long-lived binary pairs, or something more temporary and coincidental, objects that merely happened to be crossing paths at the exact moment Webb captured its images, appearing paired in a single snapshot without actually being gravitationally bound to one another at all. That distinction matters enormously for the underlying mystery. If the pairings are just a temporary coincidence of timing and position, then the original ejection puzzle mostly dissolves, since two unrelated rogue planets simply passing near each other briefly wouldn't require any exotic new physics to explain. If they're genuinely bound, orbiting each other in a real gravitational relationship the way the original 2023 paper described, then the formation mystery remains every bit as serious as it first appeared. But that skepticism didn't hold for long. Later in 2025, a separate research team led by astronomer Camilo González Cáceres examined an entirely different region of the Milky Way, a large, star-forming area completely unrelated to the original Orion Nebula survey. and found two additional pairs of free-floating, Jupiter-sized objects orbiting each other in essentially the same configuration first spotted by Webb. Caceres was notably cautious about even using the Jumbo nickname, explaining that he personally preferred the more conservative term free-floating planetary mass binaries, since Jumbo hadn't been formally adopted as accepted terminology within the research literature. But his findings mattered regardless of the name. They showed these paired objects weren't some kind of fluke or observational illusion confined to one specific, unusual patch of sky. They existed in a completely different part of the galaxy too, though the second sample suggested they might be considerably rarer overall than the original Orion detection first implied, making up only about 2% of the free-floating planets found in that particular star-forming region, compared to roughly 9% within the original trapezium cluster sample. That difference in frequency between the two regions is itself an interesting clue, hinting that whatever conditions produce these paired worlds, whether it's the density of the surrounding star cluster, the amount of available gas and dust, or some other environmental factor entirely, aren't uniform across the galaxy, and some star-forming regions appear considerably better at producing them than others. And then came the detail that pushed this story from simply unexplained into genuinely bizarre. A team of researchers, including astronomer Adam Rodriguez, turned dedicated radio telescope observations toward one specific jumbo pairing, cataloged as Jumbo 24, and detected something neither expected to find: faint, hard-to-interpret radio signals apparently coming from both objects in the pair. Detecting any radio emission at all from an object like this is genuinely unusual to begin with. The kind of radio signals astronomers typically associate with planets tend to come from magnetically active worlds interacting with a nearby star's solar wind, the same basic mechanism responsible for auroras and radio emissions detected from planets like Jupiter within our own solar system. A free-floating object with no host star nearby shouldn't have that same interaction available to power detectable radio emission, which is exactly why picking up a signal from Jumbo 24 caught the research team off guard in the first place. Researchers calculated the odds that this signal was simply background contamination from some unrelated object positioned directly behind Jumbo 24 in the sky, and found that probability to be exceedingly slim, roughly 1 in 10,000. That statistical result matters enormously because it rules out the most boring, most likely explanation, that the signal actually belonged to some completely unrelated background galaxy or star that merely happened to sit along the same line of sight as the Jumbo pair from Earth's perspective. To be completely clear here, because this is exactly the kind of detail that gets wildly exaggerated online, the researchers themselves were direct in ruling out anything resembling an artificial or intelligent source. Rodriguez explained that the fact both components of the pair emitted radio signals at broadly similar levels actually favors a natural physical mechanism behind the emission, not anything constructed or transmitted deliberately. Symmetry like that, both objects in a bound pair producing comparable signal strength, is exactly the kind of pattern you'd expect from some shared underlying physical process common to both worlds, rather than the kind of engineered, purposeful transmission that speculative claims about the signal have sometimes implied online. But that natural mechanism itself remains completely unidentified. Free-floating, Jupiter-mass objects, sitting in the near total isolation of interstellar space, aren't supposed to generate detectable radio emissions at all under any of the standard models astronomers currently rely on for planets of this type. A few tentative theories have been floated informally within the research community, including the possibility that residual magnetic activity left over from each object's earlier formation process might still be generating faint emissions, even without a nearby star to interact with, or that trace amounts of surrounding gas and dust left behind from their birth environment could somehow be involved. None of these explanations have been confirmed, and researchers have been careful not to overstate confidence in any single theory until better data becomes available. With the investigation reaching something of an impasse using existing data, the research team has applied for follow-up observation time on the National Radio Astronomy Observatory's Very Large Array in New Mexico, the same iconic array of radio dishes famously featured in the film Contact, hoping a more sensitive, dedicated look might finally reveal what's actually producing the signal. So where does this genuinely strange story actually stand right now in 2026? Jumbos, or free-floating planetary mass binaries, whichever term you prefer, appear to be real, confirmed now in at least 2 separate unrelated regions of our galaxy, which rules out the possibility that the original Orion detection was simply some kind of one-off imaging fluke or coincidence. But the 2 biggest questions surrounding them remain completely open. Nobody has definitively confirmed how a pair of Jupiter-mass objects manages to form or get ejected together while somehow staying gravitationally bound to each other afterward, with both leading theories, direct gas collapse and simultaneous ejection, still carrying serious unresolved problems. And now, layered directly on top of that original mystery, researchers have an entirely separate, still unexplained radio signal coming from at least one of these pairs, a natural phenomenon nobody currently has a working model to explain, with dedicated follow-up observations still pending as of this recording. That's what makes this a genuinely terrifying object in the most honest sense of the word, not because of speculation or exaggeration, but because it's a real, physically confirmed, actively studied phenomenon that quietly breaks multiple assumptions astronomers have relied on for decades, all at once, and the scientists closest to the data are telling you directly in published, peer-reviewed literature that they don't fully understand it yet. Simon Goodwin, one of the researchers who ran simulations specifically trying to explain away these pairings, put the broader stakes plainly, noting that no previous research had ever properly examined how long objects like these could actually persist in such a violent stellar environment, meaning even the basic survival mechanics of jumbos are only just now being seriously studied for the first time. There's something worth sitting with in just how quickly this entire mystery unfolded once Webb turned its instruments toward the right patch of sky. Free-floating planets existed in the astronomical record for over 20 years before JWST launched. A known, if poorly understood, category of object. It took Webb's dramatically improved infrared sensitivity, capable of picking out faint, cold objects that ground-based telescopes and even Hubble simply couldn't resolve clearly at that distance, to reveal that dozens of these worlds weren't traveling alone at all. And it's taken barely 2 years since that original discovery for the story to deepen twice over, first with genuine scientific disagreement over whether the pairings could even survive long-term, then with an entirely unrelated radio signal nobody predicted, or has yet explained. It's worth remembering that this entire investigation is still unfolding in something close to real time. The original 2023 discovery, the 2025 skepticism from Parker and Goodwin's simulations, the independent confirmation from Caceres's team in a completely different star-forming region, and the still unresolved radio signal from Jumbo 24, all of this happened within roughly a 2-year window, an unusually fast pace for a mystery this fundamental to unfold in modern astrophysics. Most open questions in astronomy take a decade or more to move from initial discovery through serious debate and toward any kind of resolution. Jumbos have already cycled through discovery, doubt, independent confirmation, and an entirely new, unexplained layer of mystery in less time than it took Webb itself to be built and launched. A pace that reflects both how powerful this new generation of telescopes has become and how much of the universe still remains genuinely uncharted. Even in regions of the sky, astronomers have been studying for well over a century. So here's where this genuinely leaves us, heading further into 2026. Objects that shouldn't exist by conventional planetary formation theory, confirmed now in at least 2 separate corners of the galaxy. A formation mechanism still without a satisfying explanation, caught between 2 competing theories that each carry serious, unresolved problems, and a mysterious radio signal, confirmed to be real and confirmed not to be background contamination, coming from a source that has no business producing detectable radio emissions under any current model astronomers have for objects like this. Every piece of this story checks out as genuine, peer-reviewed science. None of it has a tidy, confirmed explanation yet. That combination, real data with no clean answer, is exactly what makes jumbos one of the most quietly unsettling open questions in modern astronomy. If real, currently unresolved cosmic mysteries like this, the kind still actively being debated in published research right now, are exactly what you come here for, subscribe and turn on notifications, because between the unresolved formation question and that still unexplained radio signal from Jumbo 24, this story is nowhere near finished, and we'll bring you the next update the moment researchers get their hands on new data.